So when you see a wheelchair, you might not think of it as a robot because there's a person sitting on it, but not everybody can drive a wheelchair safely and effectively using a joystick. So we're developing smart wheelchairs that make use of sensing technology and robotic planning in order to share the control. We're developing this technology to empower people with disabilities to take control of their lives and to get on with things more independently. So in the CrowdBot project, we're working on understanding how people move around robots and wheelchairs so that we can better plan how to help the wheelchair user navigate quickly and effectively. The wheelchair has to be able to perceive its environment. And we do that through a number of different sensors. So we have a good overview using the RGBD camera at the top of the wheelchair. And then we've got a high precision LiDAR sensor at the front of the wheelchair. And that's fused with information from the ultrasonic sensors which are placed all the way around the wheelchair. Firstly, we're trying to understand better how the crowd interacts with the smart wheelchair compared with the other CrowdBot. A key difference here is the fact that the smart wheelchair has a person on board. The second key contribution that UCL is making around the notion of shared control, because the crowd will be interacting with the user, but the user will not be 100% in control of the wheelchair. In August 2019, we carried out our first experiments in UCL's Pamela lab, where we studied how a crowd of 30 people interacted with the smart wheelchair and the Pepper robot. In November 2019, we carried out some data collection on the UCL Bloomsbury campus, where we were looking to see how natural crowds interacted with the wheelchair.